So yeah, let's get started without any further ado, guys. So as discussed in the last session, today we'll be going with the first concept, networking fundamentals. Okay. This is one of the most important prerequisites for cybersecurity. For people who want to understand cybersecurity well, you need to know how devices communicate with each other and what are some important protocols that are used by these devices to send or receive data from each of these devices. Okay. So when you talk about
Hello.
networking, there are three important definitions to know. Oh,
So actually, just I joined for the first day. Actually, any previous sessions happened?
no, Chaitanya. We took one session yesterday. It was a demo session. This is the actual first class of the course. So don't worry, you haven't missed out anything. That demo, you can access it through the recording itself. The institute will share the recording to you. Or I'll
Oh,
also let you know how you can access it yourself by
okay,
the way.
sure.
Okay. So nothing to
Thank you.
worry. You haven't missed out anything. This is our first class of the course. We took a small demo yesterday, bro. You'll get the recording for that.
Okay, sure.
Right. So, as mentioned, when you talk about networking fundamentals, there are three important definitions to know, guys. What is networking? What are networks? And what are hosts? When you talk about networking, this is the practice of connecting information devices with each other. So, in an organization, you have different sorts of devices. You have routers, you have client operating system devices, you have servers, you have IP cameras, you have firewalls, whatnot. Okay. So the process of or the practice of connecting these devices with each other so that they can share the resources or information is called as networking. When you talk about a network specifically, that is the collection of those devices. Okay. So the group of those interconnected devices, those computers, servers, printers, routers, etc., which can communicate with each other, that collection is called as a network. And in that network, each of those devices individually is called as a host. So a host refers to any singular device connected to that network that can transmit or receive data. Now, just like how we humans have our names to address each other, these devices or these hosts also have their unique names. And those names are called as IP addresses, Internet Protocol addresses. Oh, just a second. Right. Apologies about that. And again, when you talk about IP addresses or Internet Protocol addresses, as mentioned, these are basically a unique identification given to each device or each host on the network. And this unique identifier, this IP address, allows for communication to occur between the hosts. Now, this was initially built by the US military in the late 1950s or so, and there were multiple experimental versions of it. There was IP version 1, IP version 2, IP version 3. Okay. What successfully worked out was IP version 4, Internet Protocol version 4. And we're still using that even in today's world. Okay. So what we'll be working on or what we'll be learning about in today's class is what IPv4 addresses are. Okay. Internet Protocol version 4 addresses are. Okay. So firstly, when you talk about an IPv4 address, it's a 32-bit address. What I mean by 32-bit is that it contains 32 zeros or ones. A bit is the smallest data value a computer or any information system can hold. It could either be equal to 0 or it could be with the value of 1. And your IPv4 address has 32 zeros or ones in it. Okay. And that entire range of 32 bits is again divided in four equal parts of 8 bits each. Each of that 8-bit portion is called as an octet, and each octet is separated by a dot symbol. So this is what typically your IPv4 address looks like in the language of zeros and ones. And does anyone know what this language of zeros and ones is called as? Have you ever heard about this language?
Binary language, binary
Correct.
programming. Yeah.
Right, it's binary. The reason why you call this as binary is because there are only two characters here, either the character of 0 or the character of 1. Okay. So your computers at their core level always communicate in binary languages itself. Okay. The 1 acts like a high frequency of data and 0 acts like a lower frequency. Okay. And when those when there's that exact sequence of frequencies sent, it understands that language or converts it into the machine level. Okay. Now, what we regularly use are decimal numbers, not the binary numbers. We don't, as humans, don't understand binary so well. So now I'm going to explain how do you convert any binary number to a human readable decimal number. So this number 11000000 can actually be converted to 192. Excuse me. This number 10101000 is actually equal to 168. This number all zeros is simply 0. And this number 00001010 is actually equal to 10. So now we'll be learning how do you convert any binary number into a human readable decimal number. Okay. Any questions or doubts up to this point, guys? Anyone? Simple and straightforward, I assume. Any
Uh,
questions?
oh, this 192 starting, it's a local IP address, right? It's like there will be global and local IP address kind. That's what
Private and
I'm.
public.
Yeah,
Yes, we'll be
private and
coming to
public.
that. Exactly. So anything starting with 190 to 168 is a private IP. But yeah, we'll come to that in a while. Okay.
Okay. Sure.
So yes. Now let's talk about the conversion here, guys. Okay. So now when you talk about the conversion, there are two simple rules to this. Rule number one. So let's say we take this number here, 10101010. And if you had to convert this into a human readable number, rule number one is you write down the values of 2 power from right to left. So under the rightmost bit, you have 2 power 0. And on the leftmost bit, you have 2 power 7. So 2 power 0, 2 power 1, 2 power 2, 2 power 3. Under each bit, you're writing these values from right to left. Okay. Once those values are written, then you multiply the lower value with the top bit. 2 power 0 into 0 plus 2 power 1 into 1 plus 2 power 2 into 0 plus 2 power 3 into 1 plus 2 power 4 into 0 plus 2 power 5 into 1 plus 2 power 6 into 0 plus 2 power 7 into 1. So no matter what the binary bits be on the top, you just write down the values from 2 power 0 all the way up to 2 power 7 and then multiply the lower value with the top bit. Okay, 2 power 0 into whatever is on the top plus, oh, let me use my pen, maybe that's better. One second, guys. My bad. Pointer options. Yeah, much better. 2 power 1 into 1 plus 2 power 2 into 0 plus 2 power 3 into 1, etc. etc. till the end. Okay. Now, once you know that is the logic, let's start calculating it. Okay. So, firstly, let me write down the values for these numbers. Anything to the power 0 is always equal to 1. It's a mathematical rule. So, 2 power 0 is 1. 2 power 1 is 2 itself. 2 power 2 is like 2 into 2, that's 4. 2 power 3 is 2 into 2 into 2, 3 times, that's 8. 2 power 4 is 2 into 2 into 2 into 2, 4 times, that's 16. 2 power 5 is 32. 2 power 6 is 64. And 2 power 7 is 128. Now that you have these values, just substitute them here. 2 power 0 into 0. 2 power 0 is 1. So 1 into 0, simply 0. Right? Then 2 power 1 into 1. 2 power 1 is 2. So 2 into 1, that's 2. 2 power 2 into 0, 0 again. 2 power 3 into 1, 8. 2 power 4 into 0, 0 again. 2 power 5 into 1, 32. 2 power 6 into 0, 0 again. 2 power 7 into 1, 128. And if you add all this up, 128 plus 32, that's 160. 160 plus 8, 168. 168 plus 2, 170. So when we humans read the number 170 as 170, the computer reads it as 10101010. So when that exact sequence of frequencies flows through a computer, it reads it as the number 170. Okay. That is how you convert any binary number into a human readable decimal number. Okay. Now I'm going to explain why this is important in a bit, guys. But did you understand this concept? Any questions regarding this? Anyone? I hope it is very simple and straightforward. Harleen, any questions? Or Jaya, any questions on your end? Perfect. Okay. Now, if this is easy and understand, perfect. So again, if you have understood this, guys, I have two other numbers here: 01010101 and all ones. Now, what I want you to do is take up, if you have a pen and a paper beside you, use these numbers and give me the decimal values for them. Example one is
All
010.
All one is 256.
And all ones. Oh, are you sure it's 256?
Yeah,
You sure you don't want to cross check it again?
1 minute. Yeah. Sorry. 2 to the power 7 is 256. Sorry. 1 minute.
2 to the power 7 is 128.
Yeah, 255, not a 256. It's a 255. Yeah.
Right. Okay. So I've got the answer for example 2. You can calculate and give me the answer for example 1 as well, guys.
Sorry to interrupt, like I'm actually unable to join. So it's asking for passcode also now, password.
Did you use the same link as yesterday, Diksha? That shouldn't cause that much trouble.
Yeah,
Passcode,
I,
passcode is
yeah,
Oh, Chetan is telling you the password.
Yeah.
394212.
394
212.
212.
Did that work, Dikshita?
Yes, it worked now.
Recording in progress.
One of the devices. Yeah, that's better.
Decimal is 85, first one, and second is 255.
Oh, I've got Haleen using example 1 is
85 decimal.
right. Okay, guys. Perfect answers. Okay. So let's try calculating them just in case if you had a different answer. So first number, as you can see, 2 power 0 into 1, that's 1. 2 power 1 into 0, 0. 2 power 2 into 1, 4. 2 power 3 into 0, 0. 2 power 4 into 1, 16. 2 power 5 into 0, 0. 2 power 6 into 1, 64. 2 power 7 into 0, 0. Okay. I'm going a bit fast because you've understood this concept. Okay. And if you add all this up, 64 plus 16, that's 80. 80 plus 4, 84. 84 plus 1, 85. Okay. And when you have all ones, you just add everything. So 2 power 0 into 1, that's 1. 2 power 1 into 1, that's 2. 2 power 2 into 1, that's 4. 2 power 3 into 1, that's 8. 16, 32, 64, 128. If you add all this up, you get the number 255. Okay. So the reason, again, no one would ever ask you to convert these numbers from binary to decimal in real time, guys. Trust me, they would never. But the reason I wanted to explain all this is you understand fundamentally what is the first IP and what is the last IP. Okay. So if now I had to get the first IP, what do? I just simply put zeros everywhere because that's the smallest number I can obtain in binary. So when I put all zeros everywhere, first IP in decimal is 0.0.0.0. Okay. And if I had to get the last IP, the other logical way is put all ones everywhere. Okay. When I put all ones, that's the maximum number I can obtain. So for all ones in an octet, I get 255. So the first IP is 0.0.0.0, and the last IP is 255.255.255.255. In your IPv4 addresses, no number will ever exceed 255. Okay, because logically, when you convert the octet 8 bits of all ones to decimal, you get 255. You cannot exceed that number. So you never have IPs in negatives or in positive numbers above 255. Whatever the IPs are, they would always range between 0 and 255 for each octet. And if we had to calculate how many IPs are there in total, each binary bit here has two possibilities, 0 or 1. Okay. And there are 32 bits in total. So for two possibilities, 32 times 2 into 2 into 2 into 2. So that way you have to go to the power of 32, 2 raised to the power of 32. And that would give you a total of 4.3 billion IPs approximately. Okay. So back then in 1950s or so, when these IPs were invented, there were no smartphones. Okay. Hardly people had internet connection and hardly people owned computers. Okay. So this was built specifically for the military purpose, actually. But later on, it transcended and it got allowed to be used by the general public as well. Okay, so 4.3 billion IPs back then was not a problem at all. It was a very sufficient number. Fast forward to today, 2025, population itself is 8 billion people, and each person again has multiple devices. That's why these 4.3 billion IPs are again categorized. There are different types of IPs. There's something called public IPs. There's something called private IPs. Some IPs can be reused infinite number of times. Okay, so we'll talk about all that later. Okay, but for now, the range of IPs is from 0000 to 255, 255, 255, 255. And the total number of IPs, if you count each and every single IP, is 4.3 billion IP addresses. Okay. And now I'm going to explain the sequence of IPs. So we know the first IP, we know the last IP. Let's talk about the sequence in between now. Okay. Any questions or doubts up to this slide? Anyone? Jaya, Harley. Because we have 32 bits in total. So 8 bits, 8 bits, 8 bits, 8 bits. So 8 plus 8 plus 8 plus 8, 32. And in each bit, there are two possibilities. So 2 raised to the power of 32. Okay, right. Others, any questions? Dikshita, Hemant, Chaitanya, Narendra, Navya, Sabarnath.
No, sir. Understood.
Perfect. Right, moving on. Let's talk about the sequence of IPs now. So as mentioned, we know the first IP. We know the last IP. What about the IPs in between? How does that sequence flow? Let's talk about that. Okay. So to explain this, I'll just take a textpad file first. Now, to understand the sequence, guys, there are two simple rules. Okay. Rule number one is you always start with the rightmost octet. Okay. Oh, 1 second. No questions. Okay. So you always start with the rightmost octet. That's rule number one. Important rule to remember. Okay. So what I mean by that is if the first IP is 0000, next IP would be 0001. So the rightmost octet increments by 1 or increases by 1. Next IP 0002. Next IP 0003. Next IP 0004. Next IP 0005. Like this, it goes on all the way up to 000255. Okay. Now, after this, can we have an IP like 000256? Is this possible? Definitely not, right? Because if you remember, the maximum an octet can go up to is 255, not more than that. Okay. So now here comes rule number two. Once the rightmost octet reaches the maximum value, then you move to the left octet. As simple as that. So the rightmost octet now resets back to 0. So this 255 cycles back to 0. And now the left octet, the one right next to it, increases by 1. Okay. So after 000255, you have 0010. Now, after 0010, don't directly jump to 0020. That would be wrong again. Remember rule number one, always increase the rightmost octet. So after 0010, you have 0011, then 12, then 13, then 14, then 15. Like that, it goes on and on and on up to 1255. Okay. And then you have 20. So this 255 cycles back to 0, and this 1 now increases to 2. So if you see there's a pattern here, 00 to 0255, 10 to 1255, 20 to 2255, 30 to 3255, 40 to 4255, 50 to 5255. Like that, the sequence keeps repeating. And somewhere down the line, you would have 2550 to 255255. I'm skipping a lot of IPs in between, guys, but I hope you're getting the pattern. Okay. Now, after 2550 to 255255, what happens next? So these two octets cycle back to zeros, and the next number changes to 1. Okay, same logic. Once the rightmost octet reaches the maximum value, reset them back to zeros and increment the left octet. Okay, and if you notice, you're back to 00 again. Okay, so this 00 again goes up to 0255. Then you have 10 to 1255, 20 to 2255, 30 to 3255. So this entire sequence repeats again. And somewhere down the line, you would have 1255255, and that changes to 200. So if you see, this is the next octets pattern, 000 to 0255255, 100 to 1255255, 200 to to 2255255, 300 to 3255255, 400 to 4255255, 500 to 5255255, 600 to 6255255. That goes on and on and on and on. And somewhere down the line, you would have 25500 to 255255255. Now all the three octets are filled. So this cycles back to zeros, and the last zero changes to 1. Now, whatever cycle repeated all the way from 0, 0, 0, 0 to 0, 255, 255, 255, same entire cycle repeats from 1, 0, 0, 0 to 1, 255, 255, 255. Same cycle again repeats from 2, 0, 0, 0 to 2, 255, 255, 255. 3000 to 3255 255 255, and similarly like that down the line somewhere you would have 255000 to 255 255 255 255, and you keep on counting each and every single IP, you would get a total of 4.3 billion IPs that way. Okay, so that is the entire sequence of IPs, guys. Okay, now this will be important in a while later on. But yeah, that's how the sequence of IPs flows. Okay. Might seem a bit confusing right now, but I'll be sharing this notepad file as well. You can go through it one more time, just in case if there's any confusion. Okay. Now, again, as mentioned, this entire sequence of IPs from 0000 to 255, 255, 255, 255, the entire 4.3 billion IPs are divided in certain categories. So these categories are called as classes, class A, B, C, D, and E. There are 5 categories. And under each class, there are 2 subcategories again, public and private IPs. So class A has public and private IPs in it. Class B also has public and private IPs in it. Class C also has public and private IPs in it. Class D and E are exceptions. They do not have any private IPs in them. They only have public IPs in them. Okay. But what are these classes and what are these public and private IPs? Let's talk about that. Okay. So firstly, let's discuss what public and private IPs are. Okay. To understand public and private IPs, this is a very good diagram. Okay. Now let me explain this. So let's assume this is our home network. Okay. Now in our home network, we might have a Wi-Fi router. And to that Wi-Fi router, we have multiple types of devices connected. You could have your laptops, you could have your smartphones, you could have your smartwatches, you could have your smart TVs, whatnot. Okay, your PCs, whatever it be. All of these devices are your intranet devices, your local network devices. So when any of these devices wants to communicate with each other, they use something called private IPs. So by definition, private IPs are the IP addresses which are used within private networks or your local networks, such as home networks, office networks, organization networks, etc., etc. These private IPs are only used for local communication. So when your phone wants to communicate with the router or your smartwatch wants to communicate with your smartphone, each of these connections happens on the private IPs. Okay. But when any of these wants to communicate with the internet, your private IPs cannot do that. They need something called a public IP for that. Okay. So your router gets a cable from outside the house. It could be an RJ45 cable or an optical fiber cable, but you get a wire from outside your house that connects to your router. That wire comes from an organization called an ISP, Internet Service Provider. Okay. So in India, I think we have ISPs like Airtel, Act Hibernate, Hathway, Ticona, etc., etc. In US, we have ISPs like AT&T, T-Mobile, Mint Mobile, Verizon. All these are ISPs there. Okay, and these organizations provide you the service of internet. Okay, so that service of internet is basically provided by a public IP. So that cable from the ISP comes to your router, and that has a public IP to it. So when any of these devices wants to communicate with the internet, so let's say if my phone wants to connect to google.com, first the phone sends the packet to the router using the private IPs. From the router now, the router is capable of sending the private IP packet to a public IP. And with that public IP, it reaches the ISP. From there, it gets routed to google.com. Okay. So public IPs are the IPs which are globally unique IP addresses that are used to identify devices on the public internet. So when you want to connect to the internet, you need a public IP. These are allocated by the internet service providers, and they're routable over the internet. Okay. And if you want to check what your public IP is, you can open up your browser. And in your browser, you can just do a quick search, what is my IP? And that shows your public IP. So if I can also click on this website here, what is my IP address.com, and that shows the same exact IP provided to me in my region by my ISP Beam Telecom. Beam is at Hibernate here. Okay. And private IPs, on the other hand, are the IP addresses used for your private devices, your internal network devices. So each device in your local network has a unique private IP. Okay. And these private IPs are not capable of directly accessing the internet. They only allow communication within the local network. Okay. And to check what your private IP is in your computer, in your laptop, you can open up your command prompt, CMD. And here you can run a simple command called ipconfig. And that shows your private IP. Now, don't worry, why am I getting this specific private IP here? 192.168 something. Why am I getting a public IP starting with 49? So there are ranges for each of these public and private IPs, guys. Okay. So we'll talk about those ranges in the next class. Okay. But now I want to go a bit more in depth on public and private IPs. Just me 1 second. Getting a call from an institute. Ahmed, 10 minute class now. Hello. 10 minute. Right. Anyways, so as mentioned, let me talk a bit more in depth on public and private IPs and how these IPs are reused. So to explain this, we'll take the same diagram again. Any questions up to this point regarding what public and private IPs are? Anyone? If you do have a question, I'm going to clarify it one more time. Right. So I want to talk about the reusability of IPs. So if you remember, I mentioned there are only 4.3 billion IPs, but they're still sufficient in today's world. How is that happening? So let's assume this is my home here. Let's call this Shoaib's home. Okay. And let's say there's one more person here. Let's say there is Chaitanya. This is Chaitanya's home. Okay. Now at my home, I have a Wi-Fi router. This Wi-Fi router is connected to multiple other devices at my network. So let's have some PCs here, some smartphones here, whatnot. Okay. Similarly, Chaitanya also has a Wi-Fi router at his home. And that Wi-Fi router is connected to multiple devices again on his network as well. Oh, sorry. Let's say there's one more device here. Okay. Could be the same number of devices, could be different number of devices, whatnot. Okay. And let's say there's an ISP here. Okay. Could be the same ISP or could be a different ISP as well. Okay. So internet service provider. Now, when you're talking about our networks here, guys, this is my own private network and this is his own private network. Okay. Now, no matter what private network you take, guys, you can repeat the same type of private IPs in any location. So in my home, my router could get the private IP 192.168.0.1. Okay. My laptop, let's say this PC is 02, or to elaborate it, 192.168.0.2. Okay. And let's say this is 03 here. This is 04 here. And let's say this is 05 here. Okay. And now the same thing, same IPs can actually be used over here as well at Chaitanya's home. So the router here could be 01. This could be 02. Oh, sorry. This could be 03. This could be 04. And this could be 05. Now you might have a question. How is this possible? How are we using same IPs? That would create a conflict. My question to you is, these are two different homes, right? So it's like you have two different families, and in those two families, you have two people with the same name. So let's say there's a person in my home with the name Adam. Okay. There's another person called Adam in another home. Okay. We two are different. How are we different? We have the same first name, but our surname could be different. That surname is something like your ISP's public IP. Okay. So your ISP provides public IPs to both these houses. So the public IP to my device, to my router could be 1, 2, 3, 4. Okay. And for this, it could be something like 2, 3, 4, 5. Okay. So an important point to note is public IPs will always be unique. Okay. What can repeat are the private IPs. So even if you have 100 million homes, in those 100 million different homes, you can use the same private IPs because none of these two homes are interconnected to each other. Okay. For that connection to happen, it always happens on the public IPs. Okay. So another important point to note is in the same home, you cannot have two devices with the same private IP again. So if this is another device, now this device cannot have an IP like 192.168.0.2 because that would now create a conflict. In the same home, you cannot have two devices with the same private IP. That should never occur. Okay. So in two different places, in X number of different places, you could use the same private IPs as many times as you want. Okay. Because they're not directly connected to each other. Okay. But when they're connecting to the internet, each of these devices will have a unique public IP. So when this device here wants to communicate with Google here, let's say there's a Google server here somewhere on the internet. This is www.google.com. Okay. So if this person wants to communicate with Google, he would first send the packet to his router. This is the private IP. And from the router, it goes to the ISP. So this connection happens on 1, 2, 3, 4. And from there, it comes to Google here with that IP. 1, 2, 3, 4. Okay. And when this guy is connecting, he would connect with his public IP. So first private IP connection, then to the router to ISP, and from there to Google. And this would be 2, 3, 4, 5. Okay. So even though we have the same private IPs, when we are communicating on the internet, our IPs would translate to the public IP there. So each of our connections would be unique with our unique public IPs. And from that public IP, it reaches the router and to our respective routers. And from there, it reaches their respective devices. Okay. So this is what reusability of IPs is. So even though we just have 4.3 billion IPs, it doesn't mean each person only gets one unique IP. Okay, so there's something called private IPs, and these private IPs can be used as many times as you want. They can be reused again and again and again in different networks. Okay, but public IPs are fixed. Okay, so there's only a limited number of public IPs. If those are all depleted, you have to go to another range called IPv6 addresses, Internet Protocol version 6. That's a much more advanced version of IP addresses. Okay. So this is what public and private addresses are playing a role on the internet. Private IPs are only for connection in the local network. Public IPs are for the internet network for connecting data over the internet. Okay. Is this clear for everyone? No, 1 second. Who's asking the question? Oh, Halil, yeah. Uh-huh. Not necessarily. Routers could be anything. You could have a Cisco router, you could have a different TP-Link router. Private IPs can be reused again because these are in your control. You can assign the private IP yourself. Okay. So the reason why they're called private IPs is because they are local to your network, private to your network. So they are in your control and you can assign any IP of your choice, which belongs to the private IP range. Okay. It is not something unique to that router. Same private IPs in their own local network. So this is your house here and this is your neighbor's house. So in their local network, their router has a private IP as well as a public IP. So the private IPs can be same, but when that router is communicating with the internet, their router will have their own unique public IP and your router will have your own unique public IP. Okay. In the local networks, private IPs can be same in 100 million homes. Okay. It doesn't matter. Okay. In my home also, I could be using the same private IPs. In your home also, you can be using the same private IPs because they're two different entities. The conflict here would arise when they're connecting in the same network, which is your internet. So for when they're connecting to the internet, they have their own unique addresses, which are the public IPs there. Okay. So it's like two people coming from two different homes and they have the same name, but you can differentiate them by their family name, by their surname. Okay. So there's Adam in house 1 and Adam in house 2. But let's say there's A Adam in house 1 and B Adam in house 2. Okay. So Adam there, the name is acting like the private IP. Okay. To differentiate them when they meet each other, they tell their surnames and they differentiate each other. Okay. I'm from A house. Yeah, definitely. Definitely, every device on the internet has its own unique public IP. So Google.com has its own unique public IP. Your ISP servers have their own unique public IP. Every IP on the internet, when you talk about public IPs, is unique. Okay, so we'll talk about those later on. Okay, right. Definitely, it will make much more sense as we progress. But for now, please remember, private IPs can be reused again and again and again in different places. Okay. Uh, Initially built by the military. Right. So there's a specific range. No, we'll talk about that also. So you can either manually assign them or you can get it automatically as well from a server called a DHCP server. But these ranges, again, were fixed by an organization called IEEE. Okay. So I think it stands for, yeah, Institute of Electrical and Electronics Engineers or so. So in collaboration with your US military, if I'm not wrong, they built these IP addresses and they decided these ranges as well. Okay. But again, we'll also learn how to assign these IPs, how do you configure these IPs. We'll talk about all that as well in the upcoming sessions. Yeah, that's what public and private IPs are, guys. I think we can stop over here. This is already confusing enough. Okay. And yeah, slowly we'll break it down and we'll digest it slowly. Okay. So yeah, that's about it. Again, a quick recap on what we have learned all already. So first things first, we talked about what IP addresses are, uh, what is networking, what are networks, what are hosts. Then we talked about IPv4 addresses and their properties. Then we talked how do you convert a binary number to a decimal number. From that conversion, we got to know what's the range of IPs, what's the first IP and the last IP. Then we talked about sequencing of IPs, and then we talked about the categories of IPs, what are public and private IPs. Phew, a long list of things. Okay. And yeah, tomorrow we'll talk about these categories in a lot more depth. What are these classes? What are the ranges of public and private IPs? And why do we have 5 separate classes? Why not just one class? Okay. Why this 5 separate entities? We'll talk about all that in a lot more detail in the next session. Okay. So yeah, it's going to be a lot more interesting. Please do join the session tomorrow on the same link at the same time. So yeah, that's that. Yeah, Jaya, go ahead. After this, again, this is a part of the certification program called Certified Ethical Hacking version 13 from EC Council. So after this course is done, you can write the exam for that certification. You're eligible or you're well knowledgeable to write that certification there. Certified Ethical Hacking version 13. This is more of a penetration testing focused course. So you can apply for security consultant, penetration tester, uh, some SOC analyst job rules as well. I think I discussed this in the demo yesterday, Jay. You'll be getting the recording for that. And that will clarify all your questions as well. Okay. But yeah, to answer that question, penetration tester job rules, yeah, to be straightforward. Okay. So we talked about the CH course. Actually, I explained about what topics we'll be covering in the entire course and all that. So you can access that recording. You'll be getting it from the institute. Sure. Okay. Uh, it's at 9 p.m. IST, Harleen. You'll have to convert it to your time zone. 9 p.m. Indian Standard Time. India time, right? Okay. And Chaitanya, you can get the recording from chat. Oh, one second, Chaitanya. I'll be coming back to you in a minute. No, nothing as such required, yet. I explained that the last of this course, no requirement of any programming knowledge required. Okay. Or it's all focused on certain tools that are used in real-time organizations, and we work on the same tools. Okay, I'll show you all those tools hands-on. Okay, so again, we'll discuss. Most of the topics are related to how do you perform attacks on various devices and how do you prevent those attacks. So there's tools for everything. We'll learn those tools. Okay. Right. So yeah, Harleen and Jay, I think we can exit the session here. We'll connect back tomorrow at the same night. Thank you guys. Bye bye. Good night, guys. Bye 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 bye. And Chaitanya, coming back to you again, as mentioned, guys, this again, you're from a different institute, right? Trained from multiple institutes at the same time. So that confusion for the first few demos. But to you guys, again, as mentioned, these recordings are being uploaded on YouTube for the first 2, 3 classes, since these are demos. So yesterday's class is also recorded and uploaded on YouTube. You can access it on DurgaSoft online in YouTube. You can search for that. And you can filter it with cybersecurity, recently uploaded video. Okay. You can get the recording for the previous session on YouTube itself. For the first 2, 3 classes, guys, only for the first few demos. After that, the students who have registered, only they will get the recordings, obviously. So please register at the earliest. The demos will be ending on Friday, which is tomorrow. And from Monday, we have registered classes. Classes only accessible to students who have registered and made the fees payment. Okay. So yeah, any questions or doubts, guys, up to this point? Chaitanya, Hemant, Navya, Savarnath, Dikshita.
I have question actually. Like, what are the tools like? Are we using some Kali Linux or something like that environment for the
We will
code?
be, Chaitanya. We work on Kali, we work on Nmap, we work on Tenable Nestles, we work on Burp Suite, we work on Wireshark. Again, I gave an entire list of tools and the curriculum in the last class in the recording. And
Okay.
just to show the curriculum today as well. This is the entire course curriculum actually available on the DurgaSoft website as well. But yeah, whatever tools I've mentioned, we'll be working on those hands-on for different parts of pen testing, network pen testing, web application pen testing. Oh yeah, you were saying something, Chaitanya?
You will, because what I know is Kali Linux and all are not free of charge, right?
No,
It's a
Kali is
paid.
completely open source.
It's open source. Okay.
Yeah, it's completely open source.
Whatever
All the
tool.
tools I'm showing you are open source. Some tools are commercial, but luckily for us, they are trial versions as well. And again, in cyber security, most of the tools are available for cracked. Okay, so I'll be sharing. If it is required, I'll be sharing the cracked version for the pro commercial version as well. But 90% of our tools are open source itself. Some will be working on the trial versions, and 1 or 2 tools will be cracked versions. Okay. Again, you don't have to pay anything for the tools. All you're paying is only for the live sessions. And with these live sessions, you'll be getting the recordings and the notes as well. Add on.
Means like whatever class are there in fees, we will get the recordings as well.
Definitely, you'll be getting the live sessions and the recordings for both. And you'll have access to these recordings for 6 months.
Recording access 6 months. Okay, and this what I can say, I can see the cryptography. In cryptography, we will go into depth, or we will just go with the introduction. And because I feel what I know is cryptography is a huge topic.
It definitely is, Chaitanya. So if you go into that, even 1 month will not be sufficient. So we'll learn on the top. I will be touching the surface, understand what are the different types of cryptography, what is asymmetric encryption, what is symmetric encryption, what are some protocols used in symmetric and asymmetric over the top. Because this is already an established concept. There's nothing to change in cryptography or establish in cryptography. All the protocols are already established. So I need to make you understand what these protocols are and how they're different from one another if questions are asked on this in interviews. So for that purpose, I've included that topic. Okay. But again, the last ones are again interview based focused topics. Okay. The ones on the top are the practical ones, understanding how to perform pen testing on different endpoints.
These malwares, trojans, or some are we learn like how to crack the softwares, or like some cracking, generating the malwares on software, what I can say,
We will
generating
be
the cracking software techniques.
Trojans mostly. How do you use these applications to get remote connections? How do you use these applications to crash systems? Okay. Malwares which can cause harm to a device. Okay, we'll be learning how to create them, detect those tools, and also how do you remove them if you have them installed on your device. So again, as mentioned, all of these topics are discussed in the session yesterday. Recommendation would be to go through that recording once.
Okay. And last point, actually, like I'm into automotive domain. It's not like computer science. I'm
Mhm.
into electronics, vehicle related things. Okay.
Right.
So how it will be helpful for me actually, because basics will be definitely helpful, whatever things, but I want to relate with that actually.
My suggestion to you would be going through this course first, certified ethical hacking, and then learning a bit more in depth on IoT pen testing. Because when you talk about automobile industry, you have again the pen testing of IoT for that, RFID
Okay.
device hacking, your car signal hacking to remotely control the car through your
Hmm.
IoT devices, Raspberry Pi devices. So
Okay.
again, learning basics of CH first, and then going towards a concept of IoT penetration testing, choosing that specialization could be very helpful. If you're planning to completely shift to cybersecurity itself, this is the go-to course. But if you plan on staying in your automobile industry itself, learn CH and learn something on IoT pen testing. I'll share the resources for that.
Okay,
Nothing.
means like that is another course is there, IoT pen
That's
testing.
another course, yeah. So again,
You
there are
mean
multiple specializations after CH. You can choose your specialization. Just like how after MBBS you have 3 years of master's program. After CH, you choose a certain specialization: network pen testing, web application pen testing, cloud pen testing, mobile pen testing, or IoT pen testing, right? So I would recommend going towards IoT penetration testing. Okay. So that would be
uh,
very helpful for automobile industry. And I'll share
but
the that.
you provide the course of for the same, or I have to check for others or
I will
IoT?
share the resources. I don't train IoT pen testing specifically. My specialization is web application pen testing, actually. But yeah,
Okay.
I do have resources which are easy to understand and learn a lot more in depth on that. But for that, you need prior basic fundamental knowledge of cybersecurity and pen testing. So that is why I would recommend doing CH first and then that advanced course. Because if you directly jump into that, you would understand nothing. Again, that is the case with anyone. So always go with the basics first and then learn the advanced concepts.
Okay, got it. Yeah, thanks for the
Hello,
No
sir.
problem.
Hemant here.
Hi, Hemant.
What about the certification process if I
You'll
complete
be
the
getting a
course?
course completion certificate,
Okay.
Hemant, after this course is done. If you're planning on writing the certification, that's a $500 certification exam. So that
Oh,
money directly goes to EC Council. And you have 125 questions, multiple choice questions in that, which out of which you have to get 70% of them right. Okay. So if you're
okay.
planning on writing, just let me know after the course ends. I can provide you the dumps required for it. I can provide some mock exams for you. And that is more than sufficient to crack the exam. But the only criteria, the only obstacle here is you have to pay $500 to EC Council to write that exam. So it's a costly certification. Okay. So if you're
Yes.
working for a company and if the company can sponsor it for you, it's perfect. That's a perfect world scenario. If that is not possible, you have to pay it out of your pocket.
So it is necessary to crack the interview or joining the company.
Again, it depends from company to company, Hemant. Some companies are putting the certification as mandatory. Some are just checking your skills through your resume and your portfolio. So there's no one definitive answer for that. So it depends on how
So
skilled you are.
your course content is sufficient for entry level
Cracking
job.
interview or for cracking the certification exam as well. Yes, it will be sufficient for both.
Okay.
Right. Any other questions, Hemant?
No, sir. Thank you.
Right. Others, guys. Sabarnath, Navya, Dikshita. Dikshita, your mic is unmuted, but I can't hear anything.
No, Shoaib. It's good for me.
Oh, okay, okay, guys. Okay. Assuming no questions further, guys, we can exit the session now, and we can connect back tomorrow at the same time. Bye bye. Have a good day. Take care. See you tomorrow, guys.